Good morning, everyone. Welcome to our e-poster session 1.2 here in S&T 2025. I am Shrif Ali. I'm co-convening this session with my colleagues, Onks. And first, we had the oral session for 1.2, which was convened with my colleagues, Ihsan and Charlotte. So thank you so much for your efforts. So we are pleased to have around 45 e-poster contributions in this session, covering a wide range of topics about the solid Earth and its structure. So we will begin with the lightning presentations. Each speaker will have 1 minute to give you a quick overview of their work. The presenters are queued here and are ready. After the lightning talk, their full e-poster will be available for viewing in the ceremonial hall from 10 to 11 a.m. So let's start with the first presenter.
Good morning, everyone. I'm here, Murad Al-Hamimat from Jordan. I will tell you about my presentation. It's about improving the crustal and upper mantle velocity model using and seismic event location accuracy using multiple seismic data network. My posters, and I will go to tell you about why the integration this network, IMS network and non-IMS network, and our local network, it's important. I will be brief. I used the Mediterranean, some of Mediterranean earthquake as a case study, and this study helping us to improve accuracy location, especially in regional event and local event. If you want to get more details, I'm in board 2. Please come to give you some details. Thank you.
Hello, everyone. My name is Maria Raila. It's a pleasure to be here. Our team from Brazil are working with a methodology described by Huang and colleagues, and our goal is to improve focal depth on transform faults of the South Equatorial Atlantic. And we started with multiple tests with synthetic data.
Probostic seismic hazard map, uniform percentile hazard spectra for rock site and the aggregation chart. The most important result for my poster, it clear from the map of big ground acceleration value. We found the highest value of big ground acceleration found in northeastern Egypt, especially near Gulf of Aqaba and Aswan, while Algeria, Libya, and Tunisia have big ground value less than 0.1. If you want to learn more about my poster, you can access it on session 1.2, 168. Thank you.
Good morning. My name is Andrea Chung. I'm from the U.S. Livermore National Laboratory. So I'm presenting on behalf of my colleagues today who are not able to attend. So the poster is about relocation of seismicity in Oman. The motivation was to understand the seismicity patterns to improve earthquake monitoring, earthquake preparedness. So for this study, we employed a two-step relocation process to relocate the catalog between 2014 and 2024 using a single event locator to first improve the locations and a multiple event locator to refine the accuracy of the locations. So one of the important findings of the study is that we were able to refine a vast majority of the onshore events who are majority are a result of construction, mining, or quarry blasts. So those are the figures in the highlighted seismicity in the blue box and the figure on the top. So if you're interested in learning about the poster, please come by this morning, and I'll be happy to discuss more. Thank you.
Good morning. My name is Charlotte Rowe. I'm with Los Alamos National Laboratory in New Mexico in the USA. And my poster is on improving 3D global propagation model using smart cables and other seafloor data. In a nutshell, we work closely with Sandia National Laboratories to build a global P-wave model, which we call SALSA 3D, Sandia Los Alamos 3D. And this model is built upon global geotest grid rather than rectangular grid. And we have worked to incorporate P-wave pics for ocean bottom stations, which often do not make their way into the global bulletins, and added those in and included those in the model. And then we further now go to look at the potential contribution that we would get from full implementation of the smart cables agenda, where the telecom cables would be instrumented all the way across the oceans in the next iteration when the current cables time out. And we can, although we don't have data from them, because the modeling produces a full resolution matrix, we are able to predict the model resolution, and that leads us to travel time uncertainty estimates and the improvements that we hope to realize via smart cables. So please, if you're interested, stop by the poster. Thank you.
Hello, I'm Annie Jerkins and I work at NorSAR, and the title of my poster is Incoherent Seismic Array Processing Using Kurtosis, a Case Study from the Grane oil field. Here we face the challenge of an offshore array with widely spaced sensors which cause weak coherence, and the idea is that we use a kurtosis-based function to recover the signal coherence prior to performing FK analysis and array processing. For our method, we first apply a bandpass filter, then we estimate the kurtosis traces, which we input into our FK analysis, which gives a clearer back azimuth and a slowness estimate, which improves our earthquake locations. The impact is that this not only works for these offshore sensors, but other sensors that also have low interstation coherence, for instance, the MJAR array in Japan. If you're interested in our poster, please come and visit us.
Good morning, everyone. I am Mona Higazi from National Research Institute of Astronomy and Geophysics, and I am working for Egyptian National Data Center. My e-poster is titled Moho Depths and Lithospheric Structure, Benisweef Siwa sector. It is part of the northern western side, western desert in Egypt. it explores 1D shear velocity model with using receiver function analysis and surface wave dispersion using joint inversion. If you are interested, please contact us in e-poster 373. Thank you.
Good morning, everyone. My name is Esther Mudise from Botswana, and our work is on the unusual earthquakes of the Central Kalahari Game Reserve in Botswana, anomalies in a stable continental plate. So our work was basically to understand why we usually get some earthquakes that are unusual to our area, because Botswana generally receives or experiences earthquakes that are low to moderate of seismicity. But we do experience some earthquakes sometimes. For example, in the 2017 earthquake, that was 6.5 in magnitude, which was significant yet unusual for our area. So we used our BSN stations, which are our local network stations that are 21 across the country, as well as the IMS stations that are in the vicinity, for example, the LBTB and Zoom in Namibia and Bosa in South Africa, to assess the seismicity and study the mechanisms of the earthquake. So our results from the aftershocks of this event in 2017, they show that the event it's probably because of an ancient fault that was previously not mapped and unknown in the area. And from our aeromagnetic data, we haven't yet mapped this fault. So from our seismicity data, there is that proposition that it could be because of an ancient quake that was previously unmapped. So if you want to further engage, please come by our poster. Thank you very much.
Good morning. My name is Mona Abdelazim Abdallah. I'm a researcher at Egyptian National Data Center at National Research Institute of Astronomy and Geophysics, Riyadh. Our poster entitled From Normal to Strike Slip, Stress Regime Transition in Egypt and Its Implication. I'd like to invite to visit our poster to explore more special distribution and the seismicity pattern of earthquake in Egypt. Also, a predominant faulting style and focal mechanism solution that shape our region. How homogeneous data provided by Kajan angle revealed that there is a change or shifting in stress regime from normal stress regime to strike slip regime in the southern part of Egypt. Our poster will be at 26, and you are welcome. Thank you.
Good morning. My name is Darius Nadi. I'm a seismologist from NDC, Australia. I will be presenting a poster about the 25 ground truth event within the period of 2002 and 2025 in Australia. We use a number of methods to make this ground truth event at scientific GT level from GT0 to GT10. That includes infrared images, seismometer in mines, temporary aftershocks kits, and also temporary seismic arrays, and some of the local and teleseismic also stations. We also relocated this event using a global 1D model and also global 3D models. We have picked for the 25 events more than, I think, 4,600 crossal and teleseismic phases, which in particular the shear wave velocity, which they have very big resolution up to from 5 to 20 seconds in Australia. So if you're interested to know more about ground truth event, come and see us, please. I'm in stage number 28. Thank you very much.
Good morning, everyone. My name is Mariam Amadi from Comoro Islands. I'm going to present to you today the title of Assessment of Local Seismic Record and the largest earthquake magnitude in Comoro Islands between 2017 and 2021. So the purpose of this subject is to kind of highlight the assessment between the data that we have used within the observatory. And from this time frame, just highlighting the 2018 earthquake swarm in the east of Mayotte Island, and with a magnitude of MW 5.9. So the purpose of this is just to kind of conclude, or not really conclude, but verify the fact that the submarine volcano eruption in Mayotte was really a volcano. So we calculated a b-value to show that the value is in the range of the volcano activity, because we have two kinds of b-value. The first one is to show that this is typically tectonic, but in our region, first of all, you need to have the geological background of the area, so that when you got the geological background of the area, then you can settle to calculate the b-value. B-value with the parameters like the magnitude of completeness, which is the first magnitude you're going to consider, then calculated the b-value. We have the value between 0.99 to 0.13, which highlights that this range of value is completely in the range of White et al. 2009, and so many authors that have already done a similar case to show that this value is really correlating with a volcano. So if you want to know more about the parameters that I have calculated to just conclude the b-value, showing that this is an underwater volcano in the east of Mayotte, so please come to my post. Thank you.
Okay, good morning, everyone. My name is Hishige, and I work in the Institute of Astronomy and Geophysics of Mongolian Academy of Sciences. And our poster is about the results of our research on the relocation of seismic events to determine the geology and structure of geological structure of the fault plains, and we specifically interested in two vertical fault lines and how they are connected underneath. And from the research, we found out that there is indeed active connection between those two vertical faults, starting from 3 kilometers to 10 kilometers. And from the relocation results, we could also clearly see that the dipping angle of the hidden fault connecting those two vertical faults. And if you are interested in this topic, come to our poster. Thank you.
Good morning, everyone. My name is Titi from the Institute and Observatory of Madagascar. My work is about creating a fault database and velocity structure for Madagascar, because lots of work were spread in different journals and seismic studies. So we have to classify all of this data into our own database. So if you are interested of my work, please feel free to come visit my e-poster. Thank you.
Good morning, everybody. My name is Raluca Dinescu. I am from the National Institute for Earth Physics, the NDC department. And our work, it's about applying the CCT method on the Vrancea region. The Vrancea region has intermediate depth seismicity with events recorded between 60 and 150 kilometers. And this complex tectonic setting and wave propagation, it could offer a reliable tool in understanding the crustal and intermediate seismicity using the CODA waveform method. The CCT method is a Java-based application that calibrates 1D narrow CODA envelopes with hypocentral distances. And and they are used to estimate stable source spectra, moment magnitude, and apparent stress. We compared our results with the results from Isola, and we got a magnitude difference of 0.3. CCT, it's offer more stable estimates across depth ranges. If you want to know more about how we applied the CCT method in Vrancea, please visit us at booth 33. Thank you.
Good morning, everyone. My name is Mary Karanja, a PhD student at University of Nairobi. My poster is about study of the Kenyan Rift using receiver function. The reason why it's interesting to do this research is because we have such a dynamic tectonic setting where we have, besides the Rift, we have the Mozambique Belt and also the Aki and Tanzanian Craton. So using this data, we were able to install a few temporary stations and also use some permanent stations that are already there. And with this work, we are able to get more insights into the crustal dynamics of the Kenyan Rift, which is going to help us to understand more on rifting and also magmatism along the rifts. The other thing that we are also planning to do is that we plan to integrate some of the seismic models that have already been done before, starting in the 90s with the CRISP. And with this, we can be able to come up with a more refined map of the Moho depth. This is continuous work, and it would be nice to hear feedback from you. So if you're interested in this work, kindly join me at my poster. Thank you.
Good morning, everyone. I'm Han Shoucheng from China NDC. It's a pleasure to be here to introduce our work about three-dimensional Lucid model and event location. In our poster, firstly, we introduced the newly developed jointly inversion algorithm, which incorporates body wave arrival times, surface wave dispersion data, and receiver functions into one system to jointly constrain VP and VS model. And the results show that the fine structure across the Moho can be well recovered by incorporation of the receiver functions. And then we collect data in southwest China and build a three-dimensional model using the jointly inversion algorithm. And finally, we collected the GT events, and based on the three-dimensional model, we conducted joint event location. And the results show that the epicenter accuracy can be improved 50% from 1D to 3D model. And in the future, this work will be extended from regional to global scale to monitor the CTBT. That's all. Thank you.
Good morning. I'm Paul Richards from New York, retired as a professor at Columbia University a long time ago, but still doing research because of work done mostly by my younger colleagues, David Scharf and Kim Wan-Young, who is in the room, in the back row there. We produce bulletins of seismicity based on waveforms that are about 100 times more precise than standard bulletins of event locations based on picking arrival times. Also, our bulletins go down to lower magnitude. In the poster, we've applied our precision methods to 6 years of continuous data from the Dongbei network in China, installed by a former student of mine, Kin-Yip Chun, on the China side of the border with the DPRK, and operated continuously for 6 years, 2004 to 2010, and find about 200 small seismic events per year during that time. They appear as clusters within about 500 kilometers of the DPRK test site. And I strongly believe that this type of precision bulletin publication has strong implications for what seismology can deliver to the broad community of people who never look at waveforms, but need the principal data product that we generate for them, whether they're journalists or people in engineering. So I encourage you to come and see poster number 714.
Good morning. I'm Mohammed Yassin from National Research Institute of Astronomy and Geophysics. My poster is about identification and classification of near-fault ground motion pulse using several algorithms of machine learning, and we show that the perfect and performance algorithm applied is SOM to our data. For more information, please visit my post. Thank you very much.
Good morning, everyone. I am Shayma Al-Khouli, a researcher at Egyptian National Data Center in National Research Institute of Astronomy and Geophysics. My poster is about ground motion and aftershocks seismicity in the region of Paphos, Cyprus, on earthquake main shocks January 2022. This study is important for seismic hazard assessment. If you want more information about my topic, please visit my poster in P1.2 870. Thank you.
So thank you all to all the speakers today for their concise and engaging lightning presentation. So unfortunately, some of the speakers couldn't make it today, so you can still explore their presentations in the CENTI website. So now I invite everyone to visit the e-poster in the ceremonial hall here at 10 o'clock. It will last until 11 a.m., where you can explore the work in more detail and speak directly with the authors. I will also be around with my colleague Monica as part of SNT team. If you need any assistance or have any questions, please enjoy the session and the great discussion ahead. Thank you so much.